Okay, since Frank Cortese couldn't make it today as he's sick at home, Alexander and myself will do his presentation. Since we've already done this one once before online, you can actually view this webinar we've done, the same slides on our YouTube channel, Frankensolar YouTube channel. So it'll be on there. And then Hazin is recording everything, so it'll be on there twice. The presentation will be on the CS 600 volt AC inverters, and it's specifically focused on why it's a good product for the Canadian commercial rooftops. First, I want to talk a little bit about what our mission is at Frankensolar and why we've brought this product on. So the mission is to assist solar installers in Canada with designing high quality and competitively priced solar projects for every home and commercial building in Canada. And we felt, specifically Alex felt, that this product fits really well into that mission. Okay, a little bit about Canadian Solar. Canadian Solar was founded originally in Ontario, 2001. It has globally over 13,000 employees and a local presence in over 20 countries and territories. As far as the Canadian market, it's got a local presence here, a warehouse and office in Guelph, Ontario. And there's local support for the inverter side of things in California. What we like about the product too is, as we're in the Canadian market, selling a product that's called Canadian Solar is really helpful when talking to a building owner. And the warranty is also great, as they're listed on the Bloomberg Tier 1 list for solar panel manufacturers, and they've been listed on the NASDAQ since 2006. As to Frankensolar and why we're a good fit and why this product is really good for us, we have over 60 megawatt that we've ordered already, and over 37 megawatts of these inverters sold since late last year. We've got a proven track record in selling inverters of multiple different manufacturers, specifically string inverters. We've got Alexander Wolf, who's doing the rest of the presentation after this. So he's our in-house electrical engineer. In general, we have a very knowledgeable staff, sales staff specifically. We've done many D ratings and over 1,000 inverters D rated. And what you get from us is unbiased support. We have not just Canadian Solar, but we've got Fronius inverters, SMA inverters, and many, many other inverters. We've got optimizers, we've got microinverters, anything, and we will help you pick the right product for your project. As you can see, that goes back to the Canadian Solar presence. That's not our presence, unfortunately. All over the world, they have local offices. As far as bankability, again, on the Bloomberg list, over 100% approval rating there for 4 consecutive years. And then the products that we'll talk about today, there's 3 products that we carry from Canadian Solar on the inverter side. There's a 100 kilowatt 3-phase 480 volt inverter. And then the product that we sell most of is the 137.5 kilowatt and 185 kilowatt 600 volt AC inverter. And then also the another product we're selling more for utility size stuff is the 255 kilowatt inverter that is 800 volt AC. That's more a product focused on 10 megawatts plus. Is this you, Alex?
That's when I take over. Thank you very much.
Just sit here.
All right. Want to get a little bit less? Or yeah, we're okay. So in this presentation, we want to cover pretty much the main topics that are important for installation in Canada that you might be facing when you design a system, when you select components, and when you finally commission those systems. Just a very quick overview. We will be talking about specifications, surge protection on the DC side, and DC oversizing. That's more on the input side. Then on the output side, what the inverter specifications are, what grid connections they can be connected to, the thermal performance, very important for the Canadian market. Then the mechanical installation, so how do you mount them and these kind of things. And then super important these days, what kind of certifications does the inverter come with? What smart features and smart grid features are within these certifications? How can you communicate with the system from a monitoring perspective? What documentation do you have available for your application? And of course, then the long-term maintenance. And at last, one quick overview into rapid shutdown options and what are the best practices for larger commercial rooftop systems. Jumping right into the inverter, or to the bottom of the inverter, you see with these very large power classes, 100, 125, 185, and 255 kA, you have a large number of DC string inputs available to you. It's not a single MPP inverter anymore, like in the older days with the decentralized systems. It's typically now similar to a more smaller CNI product, an inverter that has multiple strings directly landed. In this case, we have up to 12 MPP trackers. Each MPP tracker can have up to 2 strings in parallel, and that's a very, very good design philosophy because by code you can have 2 strings in parallel without any fusing requirements. Additionally to those separations, you have multiple MPP trackers which allow you to optimize each group of 2 strings, for example, for whatever shading scenarios on a commercial rooftop system, or if you have some long-term degradation of modules over the next 1 or 2 decades, that you have a more granular MPP tracking compared to just a single MPP tracking. That's the concept we see for a lot of manufacturers and a lot of products that are coming to market over the last probably 5 years. One really big advantage of the CSI inverter is that the inputs are designed to accommodate a very high short circuit current. And the very high short circuit current capability of the input is important for nowadays high current solar modules, specifically for modules that are also bifacial, because once we have the high ISC current, a lot of designs use a certain multiplier and a certain extra percentage on top of the ISC value for the backside production of the system. So with a 50 amp ISC current capability of each input, you're pretty much open to any current and probably for the next 2-3 years a panel size that is on the market that you're really open to monofacial as well as bifacial. Stoible MC4 connector. So Stoible is the former multi-contact company. These are the original MC4 and the brand name. And with the requirements by Code in Canada, you have to have matching connectors. In this case, your module or your home run to the inverter already has probably an MC4 because that's the standard super available. And you can directly land those MC4s on the bottom of the inverter without any whips or adjustments or searching for the specific brand connector if it would not be genuine MC4. You can also use a Y adapter in the field. That would be advantageous if the inverter is maybe a little bit further away or if you want to do some pre-combining in the field, that you have a ground mount racking system, you have 2 rows, for example. You can combine these rows in the field and then have only one conductor positive, one conductor negative, excuse me, to each input to just save cable and wiring in your system.
Is there water underneath for him?
The Stoible MC4
Just
that we
check if
have.
there's a water there for him.
Do we have water? Oh, that would be amazing. The Stoible MC4 connector that are being used here are the Evolution 2, so the second generation of the MC4. And the good news is Stoible has certified and tested them to be backwards compatible to the old MC4. So you can use MC4 Evo 2 or MC4 no matter if it's your home run or in the inverter, and it's completely compatible and code approved.
Which is, does this work?
Yeah.
Which is really important because most distributors like Frankensolar, we don't carry an Evo 2. So we don't sell the Evo 2, but we do sell the MC4, the traditional MC4, which is compatible with this. So that's really handy for, and I think the same goes for other distributors. Nobody really carries the Evo 2. I don't even know if you can
It's a
buy
certification problem currently with the Evo 2. The Evo 2 requires a double insulated conductor and a thin strand or fine strand conductor setup. And unfortunately, the RPVU 90 we have in Canada is typically a 7 or 19 strand setup, which is not certified for that new Evo 2 crimp-on option in Canada. Too much information, but typical, you use your MC4 and you connect to either MC4 or Evo 2. On the DC side as well, you see, as with most string inverters that are a dual stage concept, that you have a boost converter and then a buck converter. So boost converter on the input for the MPP tracker and then the buck mode on the actual output stage. These systems are typically 1,500 volt systems. So the maximum voltage can go all the way up to 1,500. Which means in a Canadian climate, you have a very wide input voltage range available to you and your string design. And with that system, we typically operate somewhere in the range of 860 for full power. You see here the full power of the units, all the way up to about 1,300 volts. And the entire range is actually quite wide. So even if you have, let's say, partial shading conditions or some of the panels are covered in snow, you can still use the remaining panels that are not covered all the way down to about 500 volts as long as the inverter is already in operation. The starting voltage is here at 570 volts. So for most designs, as you can see here, we have about 22 to 26 panels, depending a little bit on the location you install that system. It's different in northern Alberta than it is in southern Ontario. So Southern Ontario is very common to have 24, maybe 25 panels of the typical 72 cell standard in a string. If you go to very north and very, very cold environments, then you have to reduce that a little bit to still stay within the voltage limits if it gets to the record cold situations. Yeah. The inverter also has, like some of the other ones in that scale, DC and AC surge protection, so overvoltage protection built in. And for Canadian Solar, they actually have socket-based AC overvoltage protectors. These are metal oxide resistors and one air gap arrestor. And the capability is actually quite sophisticated at 15 or 25 kiloamps rating on the output, so the AC side. That's a typical type 2 or type 1 for the air gap. And the DC surge for each of the inputs, so we actually have 12 of those built in, is also a metal oxide resistor and has also even higher, up to 40 kiloamps surge arrestor. That is important because compared to old systems in the past where you had a combiner box and you had pretty much, let's say, 20 strings in, one combined output, you only had one DC overvoltage protector built into the combiner box. Now with these new systems, you have multiple strings separated from each other, landed directly at the inverter. So there is not a single location anymore where you could put an additional overcurrent protector. If it would not be integrated into the inverter, it would be not possible to add, or not economically feasible at least, to put additional overcurrent protectors overvoltage protectors in the system if it would not be integrated already. Oversizing is a topic we are discussing and talking to our customers and installer partners for many, many years, and specifically for commercial rooftops, that is an extremely powerful tool to look at. Here we want to just look into the maximum level. This doesn't mean that you should always go with 1.8. It's just that 1.8 would be something that you could use out of the box without any further tinkering with the system or derating. Typical DC to AC oversizing ratios, what we see in the commercial scale, is in the range of probably 1.3, 1.4, 1.5, but the inverter allows you to go even higher than that. In this case, if we pick a 130 37.5 kilowatt inverter. We will talk a little bit later in a slide about the rating here at 125/135. But with the standard, and that's the smallest one, with a standard of 125, 135, we have 9 MPP trackers, 2 strings each. And if we just pick a random Longi 550 watt panel, that would get us to about almost 250 kilowatt DC on such a unit. And if we divide that by 137.5, we get to a pretty decent 1.8 out of the box without any change. I added a quick example, a second example here, what you can do if you want to have higher DC to AC ratios. You can keep the string design exactly identical. So if the inverter is already at its maximum, because you already used all the inputs and there's no input available to you anymore, the only way of increasing your DC to AC ratio is by lowering the AC power. And that is being done by just derating the inverter from originally, let's say 137.5 to roughly 120 kilowatts or any number you like to get, in this case, in this example, to over 2-to-1 ratio. Drew?
Could you use a Y connector to throw 3 or 4 strings onto one of the MPPTs?
So electrically you could do that. The problem is code compliance, because once you have more than 2 strings in parallel, then you need overcurrent protection for your conductors and the back current to the panel.
So I guess it counts as a parallel connection.
And that counts as a parallel connection, exactly. And then you would be adding a pre-combiner box with fusing for both potentials, so positive and negative. Once you have a fuse in there, you would need an interconnected disconnect switch with the door. That is for every single MPP tracker you have, so you have that 12 times. And that's what I meant. It's not economically feasible to add either overcurrent protection or more than 2 strings to the system, because you will be spending more money for that custom-made 12-switch, bipolar fused, 1,500 volt outdoor rated combiner box that you better buy another inverter, and it's cheaper and more reliable, and you have more flexibility with the whole system. So don't do that. It's not a good idea.
Can you talk?
Don't do it.
Can you talk about why you would want to do more oversizing? Why would you derate a 185 to a 120?
So we have multiple options or ideas why you look into oversizing. And we have a special presentation for that as well, but just to grab maybe 2 topics why that would be a good idea. So in general, an oversizing of, let's say, 1.3 or 1.4 or even 1.5 in a regular application is today probably the default standard for commercial rooftop. The reason is the following. Your installation at, let's say, 10-degree tilt in a south-facing system, your panels are probably not going to produce nameplate capacity that the panels are rated under STC conditions. And your sun, for the majority of your day, is not perpendicular to your system as well. So achieving that perfect orientation and ambient condition to your string is almost impossible. And you only get higher output powers maybe in the early spring, where it's still fairly cold outside, but you already have a little higher sun angle towards your tilted solar system. At that point, you want to optimize the entire system. And you also want to optimize the system from a cost perspective. So yes, you can design the most efficient system from a technical perspective to get the most kilowatt hours out of it. That's one part. But today, more important is how can a customer or a solar installer achieve a system that has the lowest cost per kilowatt hour? And the lowest cost per kilowatt hour is, if you look into the entire system, how many kilowatt hours are you producing with a given DC infrastructure and the AC connection, your transformer, your cables, your breaker panels, your inverter you buy. Because adding more solar only costs you the solar panels, the racking system, and the labor. Everything else stays the same. And this way you can calculate multiple examples at what sweet spot you get the best bang for your buck. That's one option. The other option is, for commercial rooftops these days and the service connections customers are having, for example, we have here a 400 amp electrical service at 600 volt. You only have a certain capacity based on your busbar rating and your service size. And you probably don't want to rip out your entire service and put a new electrical panel in with higher busbar rating and then be able to add another inverter or maybe just a few kilowatts more. You want to keep the system all the way to your main breaker and your connection as cost effective as possible. And that typically means that you don't want to change an existing electrical service. So the question now is, how do you get the most AC capacity into a system that you already have or the customer already provides, in our case, 400 amps, 600 volts. And the derating can be used to dial the inverter exactly to the point where you max out your service without changing it. And then the oversizing can be used to optimize your system that you still get a lot of solar power on your roof. So it's not only, to sum that up, the most efficient system from a technical perspective, it's the most efficient system from a financial perspective. Because if a customer puts 500 kilowatts on a roof, they like the environment, but they like the monetary savings the most, typically.
If I want to can add to that, a lot of times you have contract capacity. So in the past, in Ontario specifically, we had feed-in tariffs, right? Those were typically capped at 500 kilowatts, for example. We've had out west, Saskatchewan, Manitoba had power purchase agreements that were capped at 2 megawatts AC as well. So how do you optimize that contract capacity? And a lot of times it's with oversizing, right? And yes, in this case, you can, oversize more. You buy a few extra inverters, derate them, and then you can add more panels and still stay within the limits of your contract capacity.
And this is a case-by-case decision, because every province, every system, every electrical service has different parameters. But you could use those ideas and those tools to really optimize the system specifically for commercial solar. The limits and the requirements, how far you can go, is very simple, similar to SMA, for example, or similar to other brands. You cannot exceed the 1,500 volt. That's obvious because it's a system that is up to 1,500 volts. The next part is, as I mentioned earlier, the 50 amps will give you enough capacity for pretty much any module these days, but you cannot exceed the 50. So 3 panels, for example, on a bifacial, even if you would have the fusing, would not work with that 50, with all the additional safety margins and the additional current. Switching to the AC specification, and that's part of the biggest confusion sometimes people have. Why is the 137 called a 125? Why is it not just called a 137K at the beginnings? And the reason for that is that the 185 and the 255s, it's a 255 or 185 kW active power, and the apparent power is also 185 or 255. So there's no capacity additionally available for a reactive power component. So if the utility, for example, tells you you need to have a power factor of 0.9, the inverter will automatically lose active power capability because the apparent power stays at 250 kilowatts. So for example, here we have a PQ diagram of a 185, and we can see it here. We have the reactive power and the active power up here. If we have a power factor of 1, we will be operating here on that axis. And am I correct? Yes. And you will see you have the 185 kilowatts available if you are providing 0 reactive power. Perfect. However, Canadian code is developing, and we see more and more utility companies to require a power factor that is not unity. So now they tell you, please use 0.9. And all of a sudden, at 0.9, you're somewhere here, and your power goes down to, whatever that is here, 166 kilowatts. So you buy 185 kilowatts, but with the requirement of the utility company, you can only actively use 166, because the remainder in that equation gives you the 80 kVAR reactive power that the utility company is requiring you to have. And for the 185, you have that reduction. For the 125, you have 125 kW active power, but you have 10% extra available to you, all the way up to 137.5, to provide that reactive power component without cutting into your active power. And that's a very nice feature because you get more, or you maintain your active power, even though you need to provide a 0.9, for example, power factor. The options you have available to use that power factor or that reactive power output is, the first one I just talked about is the fixed power factor setting. So utility company just tells you 0.9 it is, and you have 0.9 whenever the system is producing. You can also have a power factor that is dependent on the current output power of the unit. For example, up to 50% you're not providing any reactive power, and from 50 to 100% of P nominal of the unit, you provide, let's say, 0.9 as a linear degradation of your curve. Then there are two other models that you have a reactive power based on voltage and a reactive power based on power as well, that you're having your reactive power component depending on the voltage level of the grid. And that's one of the smart features, that the inverter is helping the grid to maintain voltage level in that Q of V function, for example, or even on the Q of P. What grid connection can it be installed with, or what secondary side of the transformer? The unit by default is a 3-wire, 3-phase system plus ground. So you can have pretty much any configuration on the secondary side, a Y or a delta. The only limitation CSI has, if you look at the entire transformer, the primary side cannot be a Y configuration. So as long as you have a YY or a delta Y or delta delta, things are work out, but a Y delta is one of the only exclusions you have. The unit at that power level needs relatively large AC conductors, and since copper went up in price significantly, for these kind of installations, most installers are using aluminum conductors. Much easier on your financials and the budgets you're allocating. And you can use aluminum on those studs with a typical mechanical lug. That's the most common installation method. They're available from multiple companies. And you transition from the typical copper terminals into a dual-rated aluminum and copper terminal. You can also use crimp-on ring lugs with a transition plate, but the most common one, as I said here, is the mechanical lug. The system, as I said, 3-phase, 3-wire, does not need a neutral, will not use a neutral, and you don't have to run that fourth conductor. You can certainly run a fourth conductor if you like to. So if you want to be future compatible to, let's say in 20 years, there is something else, or you want to do whatever, a battery storage system with a different inverter that goes into a place, or a hybrid model. Not very common, but you could run one, but not connect it if you like. Overcurrent protection for the smaller unit, the 125K, which is the 137 kilowatts, is typically a 175 amp overcurrent protection. It can go all the way up for both or all 3 units to 250 amps. And for the 185 and the 255, it would be both a 225 fuse or breaker size. Thermal specification, that's a big topic, not necessarily for Canada, but in the States. For Canada, it's a topic for low temperatures. In the US, it's a topic for high temperatures. In Canada, the 30-degree mark here for that 185 kilowatt gives you the full nameplate output power up to 30. The system is a fan-assisted system, so you have the heatsink on the back, and the fan will support the air as soon as there is a demand for additional cooling that a passive cooling with the air rising through the heatsink cannot provide. The 125 is a derated 185. So if you buy the 125, you're actually getting a 185 unit that is just software curtailed to 137.5 kilowatts, which means that you get the cooling method and the cooling system of the big unit, but you're only using it at whatever 2/3 of the actual power capability, which means that you can go significantly above the 30 degree without any limitations on the system. For a Canadian market, 30 or 40 degrees on rooftop systems is not very common. It can certainly happen once in a while on a very, very hot summer day, but it's not a problem with these systems to still operate at full nameplate output power for that. And at 40 degrees ambient, it can still produce 170 kilowatts, so we are very close to that 185 the system allows. For Canada, very specific, the warranted temperature range where the system can be installed goes all the way down to minus 40. That doesn't mean the inverter is operating at minus 40 degrees. So the operation range starts at minus 25 and goes all the way to 60, I think. Exactly. And the inverter will just wait until the internal temperature is -25, and once it is -25, then it will start the operation, and with the inverter operating, you have some power losses, the system gets even warmer, and you ramp up the power relatively quickly. How it should be and can be installed in the Canadian market, that's just a screenshot from the manual. You have a few recommendations that is perfect. So of course you can install it indoors. That's always the best case scenario for any power electronic. You want to have it protected. But you can also install that, and that's the most common scenario in Canada, directly on the roof. And we talk about a little bit later why that is the most common and the most effective way of doing it. Canadian Solar recommends that you're not installing it in direct sunlight because in the US, since this is a binational manual for the US and in Canada, it might have some additional derating if you install it in Arizona and the sun is burning on it. Then the 30-degree full power will not get you 30-degree full power anymore. For the Canadian market, it is a recommendation to have it protected, either with a little sunroof on it, but you don't have to. The system will still work and is still warranted if you place it directly in the elements. The distance here from one inverter to the other is specified at 32 inches. That's something if you line multiple units up on a rooftop rack like a unistrut directly besides the array, just for access. Bottom and below, for snow accumulation on your roof, you should have at least 2 feet. And if you place it on or underneath a little rooftop system or little shade cover, you need to have another 2 feet on top, that the heat exhaust to the top of the inverter is well dissipated and is not blocked by any cover. Most important, as I mentioned, their certification, specifically the UL 1741SB I mentioned earlier in the presentation. Going forward, more and more utility companies are requiring the UL 1741SB. The SA is already the standard for quite a few years, and pretty much every inverter in this market already has that. Going forward, Alberta, one utility company, is already forcing people to have an SB certification since January 1st of this year. We see similar requests from Hydro One coming up for some of the projects, not all of them, but slowly but surely over the next, let's say, 6 months to 12 months, we see more and more utilities requiring these large systems to have SB certification. Besides SB, it also has a bunch of other certification, even all the way to, that's part of the SB, the newest grid code, the 2021 IEEE 1547, and the communication protocol for integrated SCADA that is predefined. None of the utility companies at the moment are using that SCADA protocol, but the inverter has it, the inverter is already tested and certified with it. So for future projects, whenever the utilities are ready to implement a gateway that speaks that communication protocol, you can simplify the communication between your system and the utility for bidirectional communication. One thing I almost forgot, this unit is one of the only 1,500 volt inverters that can be used on a rooftop. And the reason for that is it has AFCI built in. Unfortunately, a lot of other US-focused inverters that are also 1,500 volts do not have AFCI and therefore cannot be used on Canadian rooftops. And that's one of the big selling features why this inverter is so popular, because you have a high power class, you have the 600 volt native voltage, and you have the AFCI under one umbrella at a very attractive price point.
Can you talk about why the US companies a lot of times don't have AFCI on their 1500 volt units?
Certainly. In the US, for rooftop installations, the voltage limit on the DC side is typically 1000 volt. So the commercial systems and C&I systems are installed with a regular 480 on the AC side and a 1000 volt on the DC side. For a 600 volt device on the AC output side, you try to have a higher input voltage to design the most efficient and the most cost efficient electronic power stage. And since 1500 is not allowed on a rooftop, this product will automatically go into a ground mount application only. Most ground mounts in North America do not require AFCI because it's behind the fence and large-scale systems. Therefore, the manufacturers typically don't include equipment and software features they don't require for the majority of their portfolio. And Canada only plays a very small role for those large manufacturers, and no one really is developing a product specifically for the Canadian market. It's typically always US market comes first, and then in a second thought, the Canadian market might be considered, and we may or may not get the right product based on what they developed for the US. Art.
Question for you on code in Canada, 1500 volt. Is that any rooftop, or is it a non?
Any commercial rooftop. So if it's a residential dwelling, the voltage is limited to 600 volts. So you're fully correct. If you have a regular residential rooftop, then you're definitely capped at 600 volts, the same as the US. Once it is commercial, then you can go all the way to 1000. Any commercial. There are some critical buildings or critical infrastructure, like I think schools have some limitations in some jurisdictions, not in others. Hospitals are something that sometimes go under these critical infrastructure rules, but also it's not a rule, it really depends on the inspector and the plan review.
For example, the inverter that's on this roof, it's not this one, but another product we carried in the past, that's also 1500 volt. The solar system on this roof.
Quick correction, we actually have two inverters on the roof.
Oh, true,
we have the 125 we are talking about here as a test system on the roof, and the second inverter, which is also 1500 volts from a different manufacturer. Most people know who it is. Quick jump into smart inverter features. Some of them are already implemented within the older current grid code, but as I mentioned, a lot more of the utility companies are asking for features where the distributed generation is participating in grid stability and fault recovery. And some of those functions, I don't want to go into it too deeply, is a Q of V function that you have additional reactive power based on voltage. We have a power function that ramps down the output power if the grid has an overvoltage condition. That's something Hydro One is also requesting for some of the projects. It's a very, not risky, but limiting feature because most grid connections are already operating at overvoltage. And if Hydro One requests that you have to cap the overvoltage at 106%, your operation window in real life is actually going or getting smaller and smaller. So you might have a lot of issues when you are remote or are at the end of the line, further away from your transformer, that the voltage is going higher and higher the more solar you feed in from the end of the line. Because now you don't have a voltage drop anymore. When you draw power, you have a voltage increase if your inverter is feeding power into the grid, leading to a possible overvoltage condition at your connection point, which leads to a shutdown of your system, even though you have no control over the actual Hydro One or any other utility infrastructure. Fault right-through is a very big topic. In the past, the inverter had to stop immediately if there was a grid fault and the frequency or the voltage went out of the spec, so overvoltage, undervoltage, and overfrequency, underfrequency. New requirement that came in required the inverter to stay on the grid for a certain amount of time to participate in fault clearance. So instead of shutting off immediately, it stays on the grid for quite some time depending on the conditions, and that's that window of operation until it has to shut down. And then some other functions that you have the P of F function. That is like a curtailment based on overfrequency. Don't want to go too deep into that again. Monitoring for commercial systems, similar to your smaller systems, is an extremely important thing because you are investing a lot of money in your commercial system and you want to make sure that the system is running as smoothly as possible and that you are aware if there are any issues, if an inverter has a problem, drops out, a grid fault, arc fault, whatever it is. CSI has three main categories what monitoring systems or what monitoring type they support. The first two are sticks you could plug into a connector on the bottom of the inverter. One stick is an Ethernet based, where you just wire up the Ethernet directly to that stick. The second option is a wireless option with just a normal 2.4 gigahertz Wi-Fi. And if you have that, of course, every inverter needs its own stick because every inverter is like its own device connecting to a Wi-Fi access point on your roof, for example. The most common one, and that is a new thing, just recently announced, CSI will provide a monitoring gateway. That gateway is very similar to any other data manager smart logger you already know from any other brand that has typically an RS-485 daisy chain from every inverter in your system and then down to your data manager or monitoring gateway. And then you go to internet or another option. If you don't want to use the CSI gateway, which we encourage you to do once it is available in the market, you can currently also use just a third-party monitoring system. So you can pick, for example, an Also Energy or a Cashlin or whichever type of third-party monitoring system you like and use the RS-485 Modbus implementation right away.
Is the gateway third-party from the same manufacturer, or is it something that CSI?
CSI will have their own gateway.
Okay.
That is coming. So announced, first test samples will come in the end of May. But once the product is available and mass-produced, we're talking about June, July timeframe for commercial availability.
Can you do multiple? So can you do the CSI gateway and the third-party monitoring?
You can do that. That's actually a very common application for larger aggregators with multiple systems. You can have all the smart features of the CSI gateway and have still a third-party monitoring system to connect over, let's say, Modbus TCP. That one is taking care of all the O&M question, where you can deep dive into all the parameters of the inverter. You can do remote firmware updates. You can do IV curve tracing and all these things through that gateway. And the third-party monitoring option from whatever provider you like is taking care of your portfolio management. So more as a high-level overview that does not go all the way in depth to every single string.
Yeah, and it's really important because if you have a lot of sites, you typically don't just have inverters from one manufacturer. You'll have SMA inverters, you'll have Fronius inverters, you'll have Solar Edge, hopefully not Solar Edge, but maybe Solar Edge inverters, and possibly Canadian Solar inverters, right? So you want to have one platform to view all your different inverter types. And at that point, the third-party monitoring platform is really handy.
Going forward, the most important thing if you start designing a system, if you start a CIA application, and if you start actually working with your engineering partner on such a commercial system is that you have your documentation ducks in a row. We have collected and worked together with CSI to provide and create most of the documents that are important for the Canadian market, that you have to have a smooth sailing in the process, that you don't have to go back to a CSI 25 times and request this document, a different document. We have all of that available. So if you have a project, we're happy to send you a data package with the most common stuff that your engineering company will need. Very, very common, for example, are short circuit current information, what contribution that inverter is having to the grid. CSI certification, for example, the warranty statements for your customer and potential financing, how anti-islanding works, impedance and sequence data. So all the technical details that the engineering company needs for successful, streamlined and effective application to whichever utility company you want to apply and connect to. On the maintenance side of things, string inverters are very, very simple compared to more conventional central inverters in that larger power frame. They're completely fan-cooled. That's the first part. At that power level, a passive cooling is not really possible anymore because you have an extremely high power density based on the size of the unit as well as on the weight of the unit, of course. So power versus weight, power versus volume. And these units still have a heatsink in the back, but a fan that is assisting as soon as the heatsink cannot dissipate the heat on its own by just rising of the hot air through the heatsink on top. The fan board is actually a slide-in module where all the fans are mounted on a tray. And you can take the fan tray out, for example, if you are installing the system in an agricultural environment where you have a lot of dust and a lot of large particles from whatever grain or whatever it is, or just a road that is very dirty, you can accumulate quite a bit of dust on those blades and on the fans, so you can take them out, you can clean them, or you can also replace them after 10, 15 years when there is a fault on the fans, and you have the possibility to do that very, very easily in the field. What we generally recommend is that for AC connections, specifically with aluminum, that you retorque the terminals at least after 1 year, probably earlier, just to make sure that you have a very, very good connection at these high current setups. Even on smaller units, this is a good idea to do. But other than that, the inverter is basically maintenance-free. There are no user-serviceable parts besides the fans I mentioned. And if there is a problem, it's typically, like many other manufacturers, a swap replacement. So if in case something happens, the inverter has a problem or whatnot, you take the inverter down, you get a new one, you hook it up to the bracket, and you send the old inverter back to the manufacturer. At the end, we quickly want to look into rapid shutdown and the best practices for commercial large-scale systems. And I have here a few thumbs up and not so many thumbs up. So I would say probably 98% of large commercial rooftop systems try not to use rapid shutdown devices and design the system instead to be rapid shutdown compliant by placing the inverter within 1 meter of the array. The code allows you to place the inverter adjacent to the array. You are still within the 1 meter. You have no uncontrolled conductors this way on the DC side, and you're automatically code compliant without any money spent on dedicated rapid shutdown systems.
Which is actually a little bit of a difference between the Canadian market and the US market, because in the US they would require module level shutdown. So a lot of the inverter companies are kind of planning around this.
Exactly. So for the longest time, module level shutdown was pretty much the forced option. Now they have some special certification where you can also do similar things like this one, but in a much more complex process that the system, your racking, your wiring is certified under one umbrella. But yeah, doesn't apply to Canada. We are very lucky to have these options open to you without jumping through many, many hoops to get there. So best practice, just the inverter, lowest cost, highest reliability, and just a simple design. If you cannot do that, because for example, your commercial rooftop system has a big array and you have smaller sub-arrays based on the layout of your roof, that there may be some HVAC units or maybe a different type of building that was added to a building that you have to bridge, then you might have a big system, let's say 60% or 70% of the system is in one big array, and just a few strings are on smaller roof segments that are further away than 1 meter each, so 2 meter total. At that point, you can only be compliant with the small one or the big one. So the best compromise here is that you install the inverter close to the largest system of your roof, the largest array, because that system is then, similar to number one, automatically code compliant for rapid shutdown. And the smaller sub-arrays, these ones you can treat with panel level rapid shutdown, certified to 1,500 volts. That would typically be a AP Systems RSDS device. And this way you have still the least number of components in your system. You have a very reliable system, but you're still code compliant for both the large as well as the sub-arrays on part of the other roofs. Both of those scenarios, in this case, will initiate rapid shutdown with loss of AC, because as soon as you have that, or you have power loss to that SunSpec transmitter, the SunSpec shutdown devices, the RSDS, will automatically go into shutdown mode and disconnect the DC.
You said SunSpec transmitter. Are these SunSpec compatible?
So that depends on the model. So the 600 and 800 volt units, since they are commercial units and are typically not being used with such a system based on best practice number one, do not have a transmitter built in. What you would do at that point, you could buy the transmitter kit from APS. That's a NEMA 4X rated cabinet with a transmitter and a power supply built in. And that's a thing that you would install just right beside the inverter and run only the strings that are affected by being further away through that transmitter box. the last option, and that has the highest dollar and only one thumbs up. You can place the inverter in your electrical room, but then you're forced to have every single panel of your system equipped with rapid shutdown. That is the most components, the highest cost, and the least reliable system. So only do that if there are no other options. And we're happy to sell you APS rapid shutdown systems, but it's not in your own interest to have that many components on these large-scale commercial rooftop systems.
And technically, you could use Tigos as well, right?
You can use Tigos as well. It's just going to be even more expensive because now you have not only a rapid shutdown solution, you also have a optimized solution plus rapid shutdown.
Which we don't generally recommend because anything you add, you'll add failures, right?
And cost.
And cost.
On the monitoring side, CSI has its own CSI Cloud Pro platform. I have a screenshot here of our system actually on the roof here. We only have one string connected as a test system, so that's a good day. When was it? I think in March or so. And here's the apps that are available for your phone or your tablet or, of course, your laptop access to the portal. You have multiple options available to you how to access that portal. It can do multiple features. As I mentioned earlier, you have bidirectional functionality to set parameters over the portal. You have the IV curve tracing that you can remotely activate. You can do firmware updates over the system. We will have a special dedicated presentation for that because it's quite sophisticated and we have to check, to allocate a little bit more time to that.
And actually what we have is an undersized system, right?
Exactly. So we have a 125 kilowatt inverter limited to a certain power class, but we only have probably 8 kilowatts connected to it. So because it's just a test system for us.
So that's why you'll see
you
the
see
curve
only a
being
small curve instead of a big curve of our 60 kilowatt rooftop system we have here in this building. A quick summary, just the biggest points why this is an extremely good fit. I mentioned most of those already. You have multiple MPP trackers, you have an extremely high power class. The 50 amp ISC current rating is really phenomenal in the industry. They're significantly higher than many other products on the market. You have a native 600 volt AC connection, which is amazing for the Canadian market for commercial because most of the connections are 600 volt as well, so you don't need a transformer to step down to 480 if you only use a 480 volt string inverter. You have string level monitoring available for every string. You have the remote IV curve tracing functions, DC integrated disconnects. You have a total of 6 disconnects for the big units or 5 disconnects for the small. It's a convection cooled system that is fan assisted. Smart grid features already fully implemented under that UL 7041SB umbrella. You have different monitoring options and you have a very, very capable DC and AC overcurrent protection, over voltage protection, built into the inverter already. And
what you didn't mention is, the price is really good as well. It's very, very well priced, and we'd be happy to quote it for you and give you a price if you don't have one yet.
Perfect. Are there any questions?